Now we are proving, students, by the help of Huygens principle, laws of refraction. First we are proving reflection. So by Huygens principles, we are proving laws of reflection. What is laws of reflection? That is, angle of incidence is equal to angle of reflection. So we have to prove this. For this, let us suppose this is any reflecting surface. A reflecting surface. Here waves are falling. Suppose the waves are falling from infinity. So I am taking two waves. One is this ray and another ray is this, and these rays are what? Parallel. So there are many more rays are coming from infinity, but I have taken the two extreme. Now how wavefront is formed? Wavefront is formed by drawing the perpendicular to these rays. So these are what? These are incident rays, and the wavefront will be formed while making an angle of what? 90 degree. So this is my angle, 90 degree. So this is the wavefront in this way. Let us suppose this is A and it is what? B. This is the wavefront. AB is the wavefront. Now every point on this wavefront will behave like what? Source of secondary wavelet. I will take two wavelets. One at point, extreme point A, another at point what? B. So to take these points, and how should I will draw the refracted ray? For that I will take this construction, small construction. I will take this much of the distance first in this way, and we will make a arc on it. इसके ऊपर हम क्या बनाएंगे? एक आर्क बनाएंगे इतने डिस्टेंस का, और यहाँ पर भी रख के हम एक क्या बनाएंगे? आर्क ड्रॉ करेंगे इस तरीके से. फिर हम क्या करेंगे? हम इन दोनों पॉइंट्स के कॉमन टेंजेंट ड्रॉ करेंगे. क्या ड्रॉ करेंगे? इस आर्क पे एक कॉमन टेंजेंट ड्रॉ करने की कोशिश करेंगे. सबके सब हम हाइजेंस के प्रिंसिपल्स के हिसाब से कर रहे हैं. अर्लियर लास्ट लेक्चर वी हैव अंडरस्टैंड व्हाट द इज दिस. तो विल ड्रॉ an arc like this by having the what? Common tangent. Let us suppose this is the thing. Oops. Now this will make an angle what? 90 degree. So this is our what? Reflected ray. In this way it is making an angle what? 90 degree. So this ray will produce furthermore. This is refracted ray. We will make another parallel ray from here in this way. So these are what? Refracted rays, and initial blue color is what? Yeah, purple color is what? Reflected rays. Now we'll draw the normals. This is one normal. We'll draw this. Here is one more normal. This angle is how much? 90 degree. This is AB. This is any point C, and this is any point what? D. This angle is what? 90 degree, because it is common tangent we are drawing, and this angle is also what? 90 degree. Now we will do the proof of this. If this is angle of incidence, so this angle is also 90. This is angle of what? Incidence. If this is angle of what? Reflection, so this is what? Angle of what? Also what? Reflection. Now we can prove it. For the proof, We will consider two triangles. In triangle A, B, D and triangle. Another triangle is what? ACD. A, B, D and ACD. We can see that the length AD is equal to what? AD. That is what? Common in both the triangles. Now we can see that angle ABD is equal to angle ACD, 90 each. And one more thing, that is BD is equal to AC, because the arc length BD and arc length is AC is what? Same. Arc length are same. So we can say that, so triangle ABD is congruent to triangle ACD. So angle CAD is equal to angle angle BAD is equal to angle CDA. So angle I is equal to what? Angle R. This is what? Laws of reflection. So Huygens has proved this by his postulates or by his principle. Now we'll prove the law of what? Refraction. So now we are doing laws of refraction by Huygens principle. What is laws of refraction? That is, refractive index of a medium is equal to sine of angle of incidence to the sine of angle of reflection is equal to velocity in medium 1 to the velocity in medium 2. This we have to drive. Now we can understand how we can drive it. Again, by geometry, we will take an interface like this. Again, what is interface? It is a thing which divides the two medium, a line which divides the two mediums. And we will see that two rays which are coming from where? Coming from infinities. Not two rays, a bundle of rays. I am taking the extreme rays from these bundles. In this way they are falling on it. So these rays which are falling on the interface. Now how we can make the wavefront? If the rays are parallel, then the wavefront is what? Plane wavefront. So we will make in this way. Y the set is square. This angle is 90 degree and this is also what? 90 degree. Let us suppose the naming is A and it is what? B. AB is a primary wavefront of these rays, and every point on AB will behave like what? A secondary source of wavelet. I will consider point B and point A for our sake of convenience. And if the velocity in this medium is V1 and the velocity in this medium is V2, and it is given that the V1 is greater than V2, it means this medium is what? Rarer and this medium is what? Denser. Now if the medium is rarer, then the light travel more in time, delta t time, and in this the light travel less distance. So we will take, this is the arc, and we will consider this much of the arc length in this way. From point S to this, we will consider it. I suppose this is the arc length. This is any point D. So the distance BD is equal to how much? V1, and the time is what? Delta t. Now in this the velocity is what? V2 and the time is delta t. So this distance is what? Less. So we will decrease this arc length little bit, and now we will make a, in this way, a arc. So there are two arcs. One is here, we have drawn earlier, and another is here, and we will draw the common tangent on them. So this is what? This is our common tangent. Suppose. Now this will make an angle 90 degree. So what we will see that the rays bending like this. So this is 90, and again we will do one more in this way. So what we can see that if this is our normal, this is our normal in this way. So this is angle of incidence. If this angle is 90 degree, so this is I also same. And here we will draw again one normal. This is angle of reflection R. If this is R and this is angle 90, this is also what? Angle of reflection R. We'll do the naming as A, B, D. This is what? C. Any point C. This is normal N1 and this is normal what? N2. Now we can derive it. For derivation, we will consider two triangles. And the two triangles are in triangle A, B, D. We will use sine of angle of incidence. That is how much? Sine theta is what? Perpendicular upon what? Hypotenuse. So what is perpendicular here? BD. And what is hypotenuse here? AD. And what is VD? V1 delta T. And it is what? AD. This is first equation I will write. Now in triangle, another triangle is what? ACD. I will write what? Sine of angle R. And this is what? This is AC upon what? Again AD. And what is AC? Here the velocity is what? V2. The distance is V2 into delta T. So this will be what? V2 delta T upon what? AD. This is second. We will divide equation 1 by 2. What we will get? We will get sine of I upon sine of R is equal to V1 delta T upon AD divided by V2 delta T upon what? AD. AD will cancel out. Delta T will cancel out. We will get sine of I upon sine of R is equal to V1 upon what? V2. And this is equal to what? Mu. Refractive index of medium 1 with respect to what? Medium 2. So this is the proof of what? Snell's law. So in this way, we are proving the law of reflection and law of refraction. So this is refraction and that is our reflection. So these two laws we are proving. Stay tuned. We'll give the next lecture tomorrow. Thank you.